Alright guys, this video is for Honors Algebra 2. It is 7.6, which is common logs. What a common log is, it's basically a log with a base of 10. So we've been working with different bases throughout the chapter on your logarithms. This is when you have a common log. It's a base of 10. It's usually written without the subscript of 10. So if you look here, you got a couple examples, log of 5 and log of 0.3. If you look at your calculator, the log, that button right here, every time you click on it, that doesn't have a base show up either. So this is the button you're using. If my finger would work, there we go. This is the log you would use if you want to just have a base of 10. So other than that, you'd have to go into your math option and get your log base program, formula, whatever you want to call it, and then use it. So what this is going to do is allow us to basically, you could do these problems that we're going to do today with any log base. The only reason we're going to do 10 is because it is right there on our calculator. So make sure you know what a common log is. Make sure you know how to find it on your calculator. It's right there. It says log. But these problems are going to look very similar to the problems we started the chapter with. As you can see, you have 4 to the x equals 19. And then round to the nearest thousandth. So what you would do then is be able to rewrite 4 as 2 squared, or rewrite the right-hand side as something to either a base of 4 or a base of 2. This time, obviously, you can't write 19 as a different base because 19 is prime. So right now, you're stuck in the problem. What you can do, though, is take 4 to the x and 19, and what you can do is take a log of both sides. Okay, just like how you can add or subtract from both sides, you can also introduce a logarithm to both sides. You can do it of any base you want to, but like I said, the reason we're going to do the common log is because it's the one that's right there on a calculator with easy access to. After you do that, now you can take, using your power rule, where am I at? There we go. You can take this x from where it is and move it to the front. So you can use your power rule backwards. So now you have x log of 4 equals log of 19. And remember that the whole goal is to solve for x. And remember that log of 4 is just a number that's being multiplied by x. So to get rid of this log of 4 that's being multiplied by x, you can divide by log of 4. Okay, so that gives you then x equals log of 19 divided by log of 4. Okay, so that's the algebra to it, and the algebra is very important. The other part, like I said a few days ago, that is very important. Sorry if I went a little quick on getting rid of that. You can back up and go look at it again if you need to. Is to make sure you know how to work your calculator with this. So when you evaluate this, the most important thing to put in, so you're going to do log of 19, most important keystroke that you hit is closing that parenthesis right there. Make sure you close the parenthesis around the top log of 19. Because if you don't, then you're going to do the log of 19 divided by the log of 4. Okay, so divide by, do log of 4, close that parenthesis. Hit enter, and as you see, you should get 2.123. I believe it said round to thousandth, so we look at the 9, means round it up. So your final answer to this is x equals 2.124. So make sure you know to close this last parenthesis. That's very, very important in this. Otherwise, the notation throughout your calculator, the setup of it, is going to be way off. You're going to have every single answer wrong. You can do all the algebra right, but every single answer, once you plug it into your calculator, will be wrong if you have that notation wrong. Okay, so then let's go back to the PowerPoint. I got a question for you guys on this next one here. Let's see, F5, there we go. I'm going to ask you guys to go ahead and work this one. You got 6 to the x equals 42, round to the nearest thousandth. Okay, so hopefully you got 2.086 for this one here. Like I said, just make sure you close that parenthesis when you do log of 42 in your calculator. It's probably the biggest mistake maker that can happen. The rest of it, the only difficult part of this is kind of getting used to notation of everything. A lot of people are uncomfortable with having the logs in your problems, but you just think of these as numbers. Okay, they're not, obviously if you do just the log of 6 in your calculator, that's a huge decimal number, and you don't want to write that over and over and over again as you're working a problem. So just think of these logs as just numbers, and you're just doing your normal algebra with them. This is where solving equations and your algebra skills comes into play very much to the forefront, because you have to be willing to work with them without them being actual numbers. It's one of the things as we go forward is going to become more prominent. It's your algebra skills and moving stuff around and everything like that. And one of those examples is like this one here. So we have solve 3 to the 5y power equals 7 to the y minus 2. Okay, so process starts the same way. We're going to take the log of both sides. So we have a log of 3 to the 5y power equals a log of 7 to the y minus 2 power. We're going to bring them both down, which is going to give us 5y log 3 equals y minus 2 log 7. Okay, now the key part is here, since you have two y's, we can't combine like terms. We've done nothing with adding logs together besides the making them multiplication. So you really can't combine logs, add them up as they sit. So what we're going to do to make this easier is a little bit of algebra skills. First thing we're going to do, since this log of 7 is just a number and its timing's a binomial, we're going to distribute this log of 7 throughout the binomial. So we're going to get 5y log of 3. So then you got log of y, here we go, y log 7 minus 2 log 7. Okay, so now we have everything distributed. We have multiple terms with y's in them right here, 5y log 3 and y log 7. So like any other normal equation, you want to get your variables to the same side. You want to get your your constant numbers to the other side. So we're going to take the variable y to the other side. So 5y log 3, subtract the y log 7 over, and that's going to be equal to negative 2 log 7. Okay, so far, just to recap, because this is a kind of long problem, what we did, we added the log into it, so that allows us to bring the exponents down in front, since the variables are up there. You distribute the log 7 through this binomial, and then you're going to subtract the y log 7 over to get the y's on the same side. Okay, so I'm going to take, since we're done with all those three, and I'm kind of running out of room, I'm going to pause here and kind of move stuff around real quick. Okay, now, instead of, like you would normally do, if it was like 2x, minus 5x or whatever, and you just make it negative 3x and combine the like terms that way, you can't do that with these logs. So you have to take another trick out of the book, and that trick is we're going to factor out a y. So we're going to go y, parentheses, 5 log 3 minus log of 7 equals negative 2 log 7. So we take a y out of each of these terms, and we're left with 5 log 3 minus log 7 equals negative 2 log of 7. Now if you look, inside this parenthesis, 5 log 3 minus log 7, that's just a number. It's a number that's being times by y. And we want to solve for this single y. That's the trick. You distribute to move this y over and to factor the y out to get it down to 1. So now to get rid of this 5 log 3 minus log 7 term, we're going to go ahead and divide both sides by that 5 log 3 minus log 7 term. To leave us with y equals negative 2 log 7 over 5 log 3 minus log 7. That's what we have to put into our calculator. Now, write that all down if you haven't yet. I'm going to get rid of it here in 3, 2, 1. Okay, so then going to the calculator with this, let's clear history. What I would do first, I would get the negative 2 log 7. So negative 2 times log of 7. Close that, and then hit enter. Alright, so that's the numerator, the negative 1.6901 blah 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 term. Now, before you move on to do the denominator, you have a couple of ways you can do. The first way, since this is a numerator, we're going to divide it, so you can do the answered pop-up trick. Okay, so answer here. It's just whenever you do the 5 log 3 minus log 7, make sure you start a set of parentheses. Otherwise, it's going to do the this part. Let me show you real quick. Back in, delete. So let's do 5 log 3. Make sure I close that parenthesis. Minus log 7. And then close that one. So if you look, there we go, back to the start. If you look at the notation here, if you follow your order ops, it's going to take the answer that you have saved here. Remember that division and multiplication go in order from left to right. So it's going to do that, negative 1.69, divide it by 5, then take that result, multiply that by a log of 3, and then take that result and subtract off a log of 7, which is nowhere near what you want to do. You want to take the 5 log 3 minus log 7 first, and then take the top answer divided by it. So what you need to do is put a set of parentheses around, let me make sure I get this right, there, yep, around your denominator. So make it parenthesis 5 log 3 minus log 7, and then the trick at the end, make sure you close the parentheses on the log 7, and then make sure you close the parentheses on the full denominator. So you need a double set of parentheses at the back end. So you hit enter, and then it should give you the negative 1.097 that you seek. A couple other different ways you could do it too. You could also do where you do the denominator first. A lot of people like that way. You still have to group it together though. So 5 log 3 minus log 7, close. Whoops, I missed a parenthesis. See that? See how you can move quick and mess up? So second, insert, close parenthesis there. Hit enter. There it is. You could store that into one of your memory spots. If you don't know how to do that, you just go store, and then you pick whatever letter you want to do. Just do alpha, I'll do A. Hit enter, and then you can do the top part, and then just go back and get it from A. There's a lot of different ways you can do it. It's going to be different for everybody. Everybody has their specific preferences. If you want to talk more about it in class, it's one of the things that we can talk about, which way is best. I don't have a preference, honestly. The only thing I really don't want to see you guys doing, unless you are very comfortable with your calculator, is programming the entire thing in at one time. Okay, because you could be one parenthesis off and it completely changes your answer. So be careful when you use your calculator for this. So as you guys can see, basically you guys have a question, 2 questions coming up. I'm going to ask you a question within the problem that I'm going to work here. And then the last one you guys are going to work on your own. Okay, so your next one is going to be 3 to the 2x power equals 6 to the x plus 1. I'm going to, the same kind of style. I'm going to go a little quicker with this one here. So we're going to take log of both sides. So log of 3. Log of 6. Oops. Log of 6. There we go. X plus 1. We're going to bring the exponents down. So 2x log 3 equals x plus 1 log of 6. Okay, we're going to distribute the log of 6 through. Hopefully you got that one right. So 2x log of 3 equals x log of 6 plus log of 6. Subtract the x term over, so 2x log of 3 minus x log of 6 equals log of 6. Factor out the x term, so x parentheses 2 log 3 minus log 6 equals log 6, and then divide. Alright, so x equals log of 6, whoops, ugly looking g. Let's try that again. There we go. Divided by 2 log of 3 minus log of 6. And make sure you show me those algebra steps, okay? Because if you show me all this and yet you just made a calculator mistake, I'm probably only going to take off a point or so. If you don't show me this setup here, then I'm going to assume somewhere in your algebra is wrong, and I'm going to be a little meaner. Okay, so whenever you plug this in your calculator correctly, I'm not going to show that, but hopefully you get x equals 4.419. Okay, we got one more question for you guys to work out, and then we got one more quick topic to talk about because it's honestly kind of irrelevant to the majority of you, but I do need to mention it just so you guys have seen it before. So here's the question that's left. Solve 4 to the y power equals 8 to the 2y plus 1 power. Okay, basic same steps as the last two have been, so nothing really changing with that. The only difference is you get a nice answer of -3/4. I'm going to ask you a second question here real quick. The question is going to be, why do you think in this example you got a nice answer? Okay, this is the only example we've done so far that we've got a nice fraction answer. Those of you that didn't put it in a fraction, you should have gotten -0.75. Even if you didn't, why do you think that is? Look at the problem, examine it, think what you write down what you think. I'm not going to count this one right or wrong. I just want to see if you can connect the dots. So answer that question. Why do you think on this example we got a nice fraction as compared to the others? Okay. Hopefully you put something to the effect. If you look at your original, and you look at bases 4 and 8, you can rewrite each of those as bases of 2, which turns this into a problem from 7.2. So I'm going to put up here that work. So you could have done that the same exact way as you would have done in section 7.2. If you see one like this and you see that shortcut, please take it. We're getting to the point where I just want you guys to solve it however you can solve it quickest. So if you see one where you can rewrite the spaces to make them the same base, like 2's here, please take the shortcut, okay? If you don't, you should still get the same answer, and it'll be nice, and it'll be a nice answer, and that's how you know that, oh crap, I could have done the shortcut way, is if you get nice answers, not, ugly decimals, excuse me, sorry. Last topic, last topic real quick we need to talk about is change of base. This used to be a lot more relevant than it is nowadays, because nowadays your calculators come with this already in it. We already talked about the log base function on your calculator. That used to not always be there. So you used to have to evaluate logs by doing what's called change of base formula. And basically what you do is you use your common log to evaluate. So what you would used to do is this. You would take, let's say you want to find log base 3 of 20. You would still use your calculator, but instead of using base of 3, you would do log of 20 over log of 3, common logs making both of them be base of 10. It's the same result. They're equivalent expressions. So for those of you that don't have the log base function in your calculator, this is how you would have to use your calculator to evaluate logs of different bases, with bases on 9s and 4s and whatever else. The vast majority of you by now hopefully have a calculator that's got the log base in it, like we talked about the other day. Just to show you, refresh you where it's at, if you pull up your calculator and you go math, and I believe it's arrow up a few times, it should be like A or towards that log base right there. Okay, so log base was what, base 3 of 20. Hit enter. You get that. The other way you could do it is use your common log. So log of 20, close parenthesis, divide by log of 3, close parenthesis, hit enter, and you get the exact same answer. Like I said, not as relevant nowadays since all the new calculators kind of have the log-based functions already in them, so it's not too big a deal. But for those of you that don't have it, make sure you know that. Alright guys, that's the end of the video. A little lengthier, but it's a pretty big lesson. So the homework tonight for this one is going to be page 496, 23, 32. As always, for this chapter, change the inequalities to equal signs.